Hello everyone. Today we're just going to go over some simple math concepts. My name is Elizabeth, or Miss Phillips, I'm sorry. Let's go ahead and dive into Module 1, Chapter 1. So our first question is going to be place the digits 8, 10, 11, 12, and 13 in the circles to make the sums across and vertically equal to 31. Is there more than one answer to the puzzle? Show all possible combinations of numbers to prove how many combinations exist which meet the rule of 31. Now, if we'll just take a quick look at our numbers, I'll go ahead and pick out a color. We'll notice that, and I'm just going to put equals 31 on both sides because we need two sets of 3 to make 31 in order to complete our bubble chart. So if we'll take a look at our numbers, we'll notice that 13 plus 8 plus 10 are going to be equal to 31. And you can run through this in your calculator if you like. We'll also notice that 12 plus 8 plus 11 is equivalent to 31. Now if we'll take a quick look at our sets of numbers, we'll notice that 8 is a common number in both equations. So once we get 8 out of this, once we realize that 8's in both of these equations, we'll kind of figure out that 8 more than likely needs to go in the middle so that it can be added to these two numbers and these two numbers. That way we get 31 going vertically and diagonally. So now what we're going to do, and we can start with either equation. We can do the 13 plus 8 plus 10 or the 12 plus 8 plus 11. For video purposes, I'm going to go ahead and do 13 plus 8 plus 10. What we can do is we can write 13 up here, and we can write 10 right here. And that way, when we're adding, going down vertically, we will have 31 altogether from those three numbers. And if you don't, let's say you don't want to put your 13 at the top, that's no problem. You can put your 13 right here, your 10 right here, and as long as these three numbers right here are equivalent to 31, it's totally fine. So now that we have our first equation in the bubbles, we can go ahead and add our second one, which is going to be 12 plus 8 plus 11. Well, since we already have our equation going horizontally complete, we can go ahead and fill in these two circles or bubbles right here. So we can put a 12 right here, we can put an 11 right here. Let's say I don't want it to look like that. Let's say I want to put it in differently. You can put an 11 right here, 12 right here. It's totally up to you, as long as all of these numbers right here are equivalent to 31 and all of the numbers going horizontally are also equivalent to 31. Now let's go ahead and we're just going to take a look at this sample diagram. This is basically an example of some of the problems we'll be doing next. If we look at our diagram, we will notice, and I'm just going to zoom this in, just to kind of see it better. So, whoops. If we study the sample diagram to the right, we'll begin to notice that 2 and 8 are going to be equivalent to 10. We will notice that, we'll make this smaller, 8 and 11, or 8 and 3 will be equivalent to 11. We notice that 3 and 5 are equivalent to 8, and 2 and 5 are equivalent to 7. So if we'll just kind of study this diagram, we'll notice that the two consecutive circles that are right next to each other, their sum together should be the number in the middle. Alright, now let's say we have this equation right here, and we're needing to solve for the 3 blank bubbles. Well, let me just switch out this color. We're given a 7, and we need to, just to get started out, we can either solve for this bubble right here, or we can solve for this bubble right here. It honestly doesn't matter as long as you kind of get started out. So for video purposes, I'm going to go ahead and I'm going to start with this one here. Well, we know that 7 plus a number, which for mathematical reasons we're going to call this one x, since we need to find this number. We know that 7 plus x will be equivalent to 15, that middle number. So in order to set up an equation for this, all we really need to do is just put 7 plus x is equivalent to 15, since we know that these two bubbles right here are going to be equal to the middle number. So an easy way to solve this equation would be to follow the PEMDAS method. We're going to start out with subtracting 7 from both sides, and our x should be equivalent to 8, which means that our blank bubble right here is just going to be 8. So we're going to go ahead, we're just going to free up that spot, and 8 will be our answer. Well, now that we have our 8, we need to move on to our next bubble. We know that 8 and that bubble right there, this blank bubble, are 2 consecutive bubbles that should be equivalent to our middle number, which is going to be 20. Well, since we don't technically know the number for this bubble right here, we're just going to go ahead and call it x again. And this is basically just a repeat process of going over it until you fill out all of your bubbles. So like we did before, we're going to do 8 plus x equals 20. And all we need to do really to solve this equation would be to subtract 8 from both sides, and x should be equal to 12. So we're going to go ahead and free up our spot, and our answer for this bubble will be 12. Let me fix that. It's not quite good enough. There we go. Now again, this is a simple repeat process, just going over it and filling in a bubble one at a time. We're going to go ahead and solve for this last bubble right here. Since we don't know the number that's in there and we need to solve for it, it's going to be x again. So we do the same setup as the last 2 problems that we've done, and we just do 12 plus x is equivalent to 17, because we know that 17 is our middle number and will be our sum of the 2 numbers next to it. Now all we're going to do is subtract 12 from both sides, and we will have 5. So now we'll just do this, and we will put 5 in our blank spot right here. And if we did this problem correctly the first time, we should be able to add 7 and 5, and we should get our sum of 12. Now if we didn't do this correctly, we're not going to get 12. So the best way to solve for this would just be to do 7 plus 5 equals 12. And you can type that in your calculator. I'm going to do that real quick, and we have 12, which means that our bubble chart is filled with all of the correct numbers. Now let's go ahead. We're going to start on the second one. Feel free to work ahead if you want. I'm going to go over this one just to kind of get the creative juices flowing, get y'all a little more familiar with our bubble charts. In this problem right here, we were actually given a 6, and we can either solve for this one bubble right here or this one right here just to kind of get us started off. As far as this video goes, I think I'm going to start out with this bubble right here. And we know that since we technically don't have a number right here, we're going to go ahead and call that x so that we can solve for it. Now we know that 6 plus x is equivalent to 13 because 13 is our sum of the two numbers next to it. We can go ahead, we can subtract 6 from both sides, and x should be equivalent to 7. So now we're just going to fill in our blank with the number 7. Now we're going to move on to the next circle. If you don't want to move on to the next circle, you're always welcome to go on to this one right here. Let's say you picked one and then you wanted to do the other one. You can always start out with this right here, as long as you have a number either right next to it right there or over here. As long as there's a number right next to it, you can start just about anywhere that you want. So for me, I think I'm going to start on this circle right here. From experience, we should know that 7 plus x, or blank, should be equivalent to 11, which is our main product of the two numbers. So we're going to write our formula, 7 plus x equals 11, and we're just going to subtract 7 from both sides, and x should be equivalent to 4. So we're just going to blank that out, take out our x, and we're going to write its true number, which is 4. Well, now we need to solve for our last bubble. Again, it's the same process over and over again. It's really not too hard once you get the hang of things. We know from experience that 4 plus our blank, which we're going to call 7 because it doesn't have a number and we're solving for it. We're going to do 4 plus x equals 19, and we're just going to subtract 4 from both sides, and x should be equivalent to 15. So we're just going to remove our x, and we're going to put 15 in our bubble. And if we did this equation correctly, we should be able to add the number we were given, the number we started out with right here, with the number that we had found last that's directly next to it. So if we'll just type that in our calculators, 6 plus 15 is equivalent to 21. Well, 6 plus 15 in the calculator gives us a total sum of 21, making our equation true. Alright, I'm going to go ahead and let you work this out on your own. Once you get through with the equation, the problem, you're welcome to unpause this video. We'll work through the question, and you can figure out where you might have made some errors, and we can go from there. Let's see, we'll start out with blue. We're given an 8, and we can go ahead and solve for either this bubble right here or this bubble. I like this bottom right one right here, so we're going to solve for that one. Since we don't have a number for it yet, we're going to give it an x. We're going to call it x, and we're going to set up our equation. Since we're solving for our big sum of 18, and we know that 8 plus x will equal 18, all we need to do is write up this equation right here, and we can begin to subtract 8 from 18, leaving us with a solution of 10. So we're going to go ahead, we're going to write 10 right there. And now we're going to solve for this next circle. Well, we know, since we don't have a number, it's going to be x. So 10 plus x should be equivalent to 16. And then all we'll really need to do is subtract 10 from both sides. and x should be equivalent to 6, which will be our new blank right here. Then we're going to solve for this last bubble. 6 plus x should be equivalent to 7. Subtract 6 from both sides, and x should be equivalent to a 1. So we're going to erase that, put a 1. And then just to double check our equation to make sure that we have everything right, we are going to add 8 and 1, and it should give us a total sum of 9. So 8 plus 1 equals 9. And if you really want to, you can use a calculator. I just did mental math. You should get 9, which is our total sum. Therefore, this will be the solution to the next problem. Or to this problem, I apologize. Now moving on, we're going to go to this next problem. The question is, sketch all possible figures which can be formed and calculate the perimeters of each figure that can be formed. So the perimeter is the distance around the figure, and we'll go ahead and just zoom in right here, just to give a little example. So this figure right here to the left, figure 1, that is too thick. Figure 1 is going to have a perimeter of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It's going to have a perimeter of 18 units. Since we technically don't know what the measurements are, we're going to call them units. And figure 2 should have a perimeter of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Should have a perimeter of 16 units. So that's basically what this whole problem is going to be. If you'll notice, I've already taken the liberty of drawing out just a couple of simple shapes. Unfortunately, with just a 9-block figure like this, you're limited on the number of perimeters you can get. You're welcome to go ahead, pause this video, see how many figures you can draw, how many different kinds of perimeters you can get, and then whenever you're ready, go ahead and just unpause this video, and we will kind of go over how many perimeters you can get from this figure and how to determine them and so on and so forth. So with this first figure, figure A that I drew, it's a 9x9 block. I believe it is going to be the smallest perimeter that we can actually get out of a 9-block figure. So in order to find the perimeter of this one right here, we're just going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or, if you want to do this the fun way, you can count 3 right here, 3 right here, and you know, since this is a square, it's going to be 3 plus 3 plus 3 plus 3. We'll change the color just to kind of 3 plus 3 plus 3 plus 3. So the perimeter would be equivalent to 3 plus 3 plus 3 plus 3, or it's going to be 12 units. Now for this next figure right here, we really can't do the same trick for this one just because it's an odd shape. What I did to find the perimeter of this is I just kind of counted around. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 units. So we're going to go ahead and write 14 units for a perimeter. And then for this last figure right here, we technically can do the same trick with this one, but since it's just a straight line, it's really just as easy to add everything up. So we have 1 on each side, 1 plus 1, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9 on each side. So it's going to be plus 9 plus 9. Our perimeter altogether, if you just kind of add this in the calculator, is going to be 20 units. And as far as a 9 by 9 blocked figure like this goes, the main perimeters that you're really going to find, even after rearranging the shape, are going to be 12, 14, 16, 18, and 20 units. So let's go ahead. We're going to take a look at our perimeters here in just a sec, kind of determine this. We already know the answer to both of these questions just from going over our perimeters and our figures that we drew and determined. This first question is basically saying which figure has the least perimeter, and the second question is which has the greatest perimeter. So if we'll look back, right here, we know we have, we'll get a new color. We know we have a 12 units, 14, 16, 18, and 20. Now, out of all 5 of these perimeters, I would like to think that 12 units is going to be our least, or least probably isn't the best word. Let me see. Well, least is a good word. It fits the question. So it's going to be our least perimeter. And if we'll kind of look over, 20 should be our largest perimeter here. So we're going to go ahead and write largest right next to that. And that way we know that has the largest perimeter and A has the least perimeter, or the smallest. Now on to the next question. I went ahead and drew these figures out just because it makes it a little easier to kind of concentrate and focus on the figures. As far as this goes, it's basically just adding a new layer of dots on the upper left, upper right, and right hand side of the figure. This is actually a pentagon that they're just adding some extra layers of dots to. So for this first figure, we only have one dot, therefore 1 will be equivalent to 1, and we have 1 dot in total in that figure. For the second one, we have 1 plus 4 is equivalent to 5. That's basically talking about the new layer of dots being added. We originally started out with this 1 dot right here, this orange dot, and then we added 4 of the blue dots. So since we added 4, it's going to be 1 plus 4, which is going to leave us with a total of 5 dots in that figure. For the next one, with our next layer that was added, we actually got a layer of pretty purple dots that have a total of 7. So all we do is add this new layer of dots to what we already have, 1 plus 4, which is 5, plus 7, which is going to be equivalent to 12. And then if we'll just look at our fourth figure, we will notice that, and let me see, we have 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13. Oh, I'm sorry about that. That's the wrong figure. We're looking at the fourth figure now, which is going to be this guy right here. And as far as this guy goes, this green layer of dots should be equivalent to 10, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore, 1 in our first figure, 4, which was added in our second figure, 7 added in our third, and 10, which was added in our fourth, will be added together, and we will have a total of 22 dots making up the figure. So let's say I want to find out the 5th, 6th, 7th, and 8th figures, like the total number of dots in each figure. Well, whoops. If we'll just go ahead and look back at our equations, there's actually a pattern that kind of helps us determine what the number of dots will be in the next sequence. So we're going to take a look. We'll go ahead and copy the fourth sequence onto our next page, 1 plus 4 plus 7 plus 10. We'll do it down up here. So we know that 1 plus 4 plus 7 plus 10 should be equivalent to 22. Now if we'll look at our numbers right here that are being added together to find our total sum, we'll notice a pattern. We'll notice that 1 plus 4 is adding 3, or 1 to 4 is adding 3, 4 to 7 is another 3, 7 to 10 is adding another 3. Therefore, since we have this pattern going on, we should be able to determine that our next number is going to be 13. And if our next number is going to be 13, all we're going to do is just do plus 13, and we're going to whip out our calculator. I've already got mine in my hand. Let's see. Come on, calculator. We're going to do 1 plus 4 plus 7 plus 10 plus 13. And our total number of dots in this next figure should be 35. You're welcome to go back, look at the fifth sequence of fifth figure of the sequence, and you're welcome to go back, count the dots, just see how many are there. I'm not going to do it because of time purposes. You will notice that there are going to be 35 dots altogether in that figure. Since we know 13 was our last number and we're adding 3 to every number in our equation, which we can actually probably view this as more of a sequence going up, 3 every time, we'll notice that our next number after 13 should be 16. We'll go ahead, we'll do 1 plus 4 plus 7 plus 10 plus 13 plus 16. We're going to whip out our calculators, and our overall total for that next sequence should be 51. Now for the seventh equation, we're just going to add another 3 to the end. 16 plus 3 is 19. So it's 1 plus 4 plus 7 plus 10 plus 13 plus 16 plus 19. And we should have our total of 70. We'll write that down right there. And you're always welcome to go back, draw the figure, double check it if you want. Since the figure does get so big in the end, it's honestly time consuming and it's probably not your best method. Looking at the 8th sequence, we left off at 19, so there is a 99% chance that our next number is going to be 21. I'm sorry, 22. 19 plus 3 is going to be 22. So all we're going to do is 1 plus 4 plus 7 plus 10 plus 13 plus 16 plus 19 plus 22. And that is a lot of writing. We'll go ahead and add 22, and we should get a total sum of 92 dots for the next sequence. Now, for our next question, question number 4, this is a fun kind of equation. It's actually just starting out with pyramids and finding out the numbers in the blanks. So we're solving for these 2 blanks in this equation. Basically, as far as this kind of question goes, we'll notice that 7 plus x should be equivalent to this blank right here, and 7 plus 3 should be equivalent to this blank right here. And when you add these two blanks together, they should equal 25. So just to kind of get started off, we'll go ahead and start with this right here, 10 plus 7, or x plus 7, I apologize. I'm sorry, I meant to say, because we're going to have to solve for our x in order to find our blank. Our best bet would be to start out with 7 plus 3. So we're just going to write our equation 7 plus 3, which is going to be 10. And since we know 7 plus 3 is going to make this number up here, we know that that blank right there should be 10. Well, now we want to solve for the next problem. We want to figure out what this blank is right here in order to solve for x down here. Well, just an easy way to solve for that blank would be to subtract 10 from 25. And here's why. From our simple run through of this equation, we know that this square right here, or rectangle, I'm sorry, and this rectangle right here will be equivalent to the number on top of them. So in order to get that final product, we'll need to take 10 away from 25 in order to find our new number, which is going to be 15, or a blank number, I apologize. So we'll put 15 right there. And if you'll notice, you can type this in the calculator just to double check it. 10 plus 15 is indeed equivalent to 25. So now that we have our 15, we can go ahead and we can solve for x. Since we know, and I'm going to get a bright color for this, since we know that x and 7, when added together, are going to be 15. All we really honestly need to do is set up an equation similar to the last one. 15 minus x is equivalent to 7, since that's what we're solving for. And our total should be 8. So now we know that our x right here is going to be 8. And we can double check that by adding 8 plus 7 on our calculators, and we should get a total of 15. So this is going to be the answer for this table. Now moving on to the next question. You're welcome to pause this, go over it if you'd like. We know that we need to solve for this blank right here and this blank right here. We also know that 1 plus y is equivalent to the first blank. Y plus 2 is equivalent to the second blank, and 15 is our overall sum. Now, the unique thing about this question is that since our y is in the middle, and we really can't find any numbers this way, but we know that 1 plus y makes this the first blank, and y plus 2 makes the second blank, and then once those blanks are added together, they'll make 15. All we really need to do is replace the numbers for our blanks with the equations that make them, if that makes sense. So what we're going to do for our first blank right here, we'll get another color. For our first blank right here, we're going to put 1 plus y. And you can do parentheses if you'd like. It really doesn't hurt anything. And then for our second blank right here, we'll get another color. For our second blank right here, we're going to do y plus 2. So 1 plus y plus y plus 2 should be equivalent to our overall total of 15. Now, when we go over this problem, we'll notice that 2 plus 1 is 3, and y plus y is going to be 2y, which will be equivalent to 15. And then all we need to do to solve for y would be to subtract 3 from both sides, to y equals 12, and then divide it by 12, or 2 on both sides, and y should be equivalent to 6. So if our y right here is 6, we should be able to find out the solution for our two blanks. We know that 1 plus 6 right here will be equivalent to this blank right here, so 1 plus 6 is going to be 7. Therefore, this blank will be 7. We also know that 6 plus 2 will be equivalent to this blank up here. So 6 plus 2 should be equivalent to 8. Therefore, 8 should go right there. You're welcome to go back, double check this if you like. 7 plus 8 should be equivalent to 15. 1 plus 6 should be 7. 6 plus 2 should be 8, and so on and so forth. Now for our next problem, this is just a fun little kind of word game to figure out who's married to who in a scenario presented to us as a problem. So to get started with this, I'm just going to get some red to kind of fit the mood, and we'll go ahead and read this question. It states, 4 married couples belong to a bridge club. The wives' names are Kitty, Sarah, Josie, and Ann. Their husbands' names in some order are David, Will, Gus, and Floyd. Use the table below to sort out who is married to whom. Use transitions in your presentation to engage the learner in your lesson. So, starting out on this problem, we're going to go ahead. We're just going to read from our clue box first, see if we can get anything from that. Our first clue is that Floyd is Josie's brother. Well, since Floyd's Josie's brother, there's a really good chance Josie won't be married to Floyd. Our next clue states that Josie and Gus dated some, but then Gus met his present wife. Well, if Josie and Gus only dated some, and he's already found his present wife, there's a really good chance that Josie will not be married to Gus. So we're going to go ahead and mark him out on our chart. And then for our next hint, we'll notice that Kitty is married to Will. So we go over to Kitty's chart. Since Kitty's married to Will, we can go ahead and put a green check mark right there. And we can go ahead and mark out all of the other guys on her list simply because we already know who she's married to now. For our next hint, Anne has 2 brothers. Okay. That doesn't seem like a useful hint at the moment, but it might come back to help us later on. So we're just going to go ahead and we're going to put a little red dot right there so that we remember to come back to that. Our hint after that is that Anne's husband is an only child. Well, Floyd is Josie's brother, so Floyd is not an only child, making it to where Anne is not married to him. And now that we are, I believe, as far as we really can go on this problem, we can take a look at our chart down below and we can fill in the rest of the blanks. Super easy. We're going to start out with Josie. Since Kitty is married to Will, Josie can't be married to Will. Sarah can't be married to Will, and Anne cannot be married to Will. Well, we know Josie isn't married to Will. She's not married to Floyd. She's not married to Gus. Therefore, there's a good chance that Josie will be married to David. Again, since Josie's married to David, Anne cannot be married to him, and Sarah cannot be married to him. Well, on Anne's column, we'll notice that she's not married to any of the first 3 guys. She has one blank left, so it's safe to assume that she ended up getting married with Gus, or married to Gus. And since she's married to Gus, Sarah cannot be. Sarah only has one blank left on her column, and nobody else is married to that gentleman. Therefore, Sarah will be married to Floyd, and this will be the solution for our problem. Now, for this next problem, this is a little messy. I tried to incorporate the question. It actually didn't pop up for my first recording. The question says, create a dot pattern representation of the trapezoidal numbers. Notice that 1 plus 1 plus 1 is equivalent to 1 times 3, and so on. Well, sorry. An easy way to figure out the dimensions of a shape like this one that's really not changing too much or going crazy, a good way to figure out what the dimensions are would be to do start out on this side or from the bottom. You only have one row of dots on this side, so it's going to be 1 by, and then you'll do this side right here, which there are 3 dots right there. Therefore, it's going to be a 1 by 3. Again, you have this equation right here. Let's say I don't want to write all of that out. I just want the dimensions. Well, you're going to take a look at one side. You'll notice that there are 2 dots right there. And then you take a look at this side, and you'll notice that there are 4. Therefore, our figure will have the dimensions of a 2 by 4 figure. Again, with this third one, it's really very simple. You just count the sides. You got 3 by 5. Therefore, the dimensions will be 3 by 5. Now, believe it or not, there's actually a formula that you can use that works just as well. And this formula is going to be n times n plus 2, which oddly enough works out pretty good. So n is going to represent the sequence number that you're at, which let's say I'm doing a 2 by 4, or I'm doing the 2 by 4 figure right here. What I can do, since that is the third figure, oh, sorry about that. What happened to my question? Okay. N is going to equal the number, or the sequence you're in. Honestly, as far as these figures go, the dimensions of this one's going to be a 2 by 4, this first one, and it is the third part of the sequence, or of the sequence. So, what we're going to do, we are going to do a 2 by 4 figure, and we know that it is the third or fourth sequence? The third sequence. And now all we need to do is fill in a 3 for every n that doesn't have a number in our equation. So we started out with n times n plus 2, which eventually, once we figured out the right numbers, we got it to where it is 3 times 3 plus 2, and a simple way to follow, or to add this, take care of this, would be to, what is it? The best way to solve this equation would be to follow the rules of PEMDAS. So first we're going to start with our brackets. We're going to do 3 plus 2, which is going to be 3 times 5, which will in the end be equivalent to 15 units or dots. Which we'll go back, we'll check our work real quick. I believe, I'm sorry, I did the third sequence. I did not write down the right figure. Our figure is not a 2 by 4 figure. It is actually a 3 by 5, which means that we're going to write down 3 by 5, and that should be it for today, guys. I hope you have a great day. Make good choices. If you need any help from me, go ahead and shoot me an email, send me a text, whatever you need to do to get you back on the right track. And I will see you guys later.